guys, in this little video we're going to look at some of the different carbon stores that we can find around and about. One that we often don't consider as a carbon store or a reservoir of carbon is peat deposits. Now peat isn't just a nice name, it's actually a substance, right? It looks a bit like soil. You can see a peat bed in this image over here. It looks just like big thick brown soil, and that's really exactly what it is. Peat lies quite close to the surface, so it's really accessible to people who want to get it. Okay, it's sort of composed of organic matter, so dead plants, dead insects, dead animals that have been compressed to form this sort of substance here. It's only partially decomposed, it's not fully decomposed. Now peat is a really effective carbon sink, and it's estimated that there's about 550 gigatons of carbon in peat worldwide in peat reserves. So how do we get from just going from soil or dead organisms to peat? So what happens is dead leaves are digested by bacteria and fungi. You see this term here, saprotrophic. Saprotrophic just means it's bacteria and fungi breaking down matter. So saprotrophs will assimilate some of the carbon and can release carbon dioxide through respiration. If the soil becomes waterlogged, it will become anaerobic, and that will prevent these saprotrophs, these bacteria and fungi, and another type of group of bacteria called methanogens, from breaking down the soil anymore. So we've only got partially decomposed matter. Okay, and as that partially decomposed matter builds up, it compresses and slowly becomes peat. Now, if it's not decomposed enough, it may go back round, it may form acidic conditions, and that may further inhibit these bacteria. What happens to peat in time? Well, if peat gets further compressed on land with further pressure and further time and more heat, coal will start to form. So you can see this with the transition from peat, heat, pressure, time, down into coal. Okay, and there is still a relatively large amount of coal reserves out there, but again that is dwindling, okay, due to over reliance on fossil fuels. Oil and gas is slightly different. Oil and gas, as opposed to forming on land, they form under the oceans, and it's the result of lots of those tiny sea plants and animals settling on the bottom of the ocean floor and being compressed over time. When we're talking about natural gas, we're actually talking about the gas methane, CH4. That is the natural gas that we're talking about, and that is released and from under the oceans. Also importantly, we can talk about animals, and we know that there are carbon stores sometimes in the shells of different organisms. So some animals will secrete calcium carbonate, CO3, to protect themselves. So the shells of mollusks and the hard corals of exoskeletons. So mollusks, we're talking about things like mussels and snails and other gastropods. So when those animals die, the soft body parts will decompose, but the hard parts, the calcium carbonate parts, will remain as deposits on the ocean floor. Those deposits get buried, compressed, and eventually form limestone rock, and these are what we see all around Bali today. And you go down to the Bukit and you look at those cliffs, they're all made of limestone, and you can see these prints of shells within them. And so limestone is another big carbon sink. It's a huge store of carbon in the form of this calcium carbonate. Now what happens, of course, is if these biomass forms are burned, okay, peat, calcium carbonate, or coal, oil, gas, if they're burnt, the combustion reaction that comes from that will release a lot of CO2 into the atmosphere, okay, and that is causing problems of its own, causing carbon levels in the atmosphere to rise. Last slide and last thing we're going to talk about is methanogenic bacteria. So we talked before about saprotrophic bacteria that break down microorganisms, bacteria, fungi, which break down dead things and turn it into peat. Well, methanogens are a type of sort of specialistic sort of bacteria that produce methane as a metabolic byproduct of anoxic conditions. Anoxic means without oxygen. So what they're doing is they're using organic matter where there is low oxygen concentrations, so they're respiring anaerobically, and they're producing methane as a byproduct. So areas where these bacteria are commonly working are wetlands. Anywhere there's water, it becomes anoxic. So wetlands are a common area for methanogenic bacteria. Digestive tracts of animals like cows. This is why cows, humans, and termites, we all produce methane, okay, through flatulation, through trumping or farting, whatever you want to call it. Marine and freshwater sediments, okay, because they're waterlogged, they're anaerobic. And the last one is landfill sites, are huge producers of methane through partial breakdown of organic matter by methanogens to produce methane. So there we have it. A lot of information. Please pause, go back, make your notes. It is important information. You could be tested on it, and thank you.